Yeah, let's do this. All right, it is 5/18/22. It's Mount St. Helen's Day. It is Mount St. Helen's Day today.
Why is it watering?
Was that 42 years ago?
Can we watch the video of how
Later on we will. I think that'd be fun. Okay, so our objective today is actually going to be solving rational equations. So again, the word rational is just a fancy word for fraction, okay? Yep. Fancy word for fraction. So, rational. You'll see that in your SAT exams, and you'll also see that on your state test. They'll use this word. They'll say rational number. They'll use that word, and you know, any number that can be a fraction, is a rational number, okay? The only ones that aren't are things like pi, the number e, or square numbers, right? Ugly square numbers. Most other numbers are going to be you can make it into a fraction, right? Okay, so the biggest thing we have to be careful of are excluded values. So, for example, in example 1, if x equals -8, if we do all the solving and we get all the math, boom, 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 and we get x equals -8, we throw it away because x cannot equal -8, right? And x, yes, cannot equal 3.5. So my excluded values are x equals -8 and x equals 3.5, okay? Those are my excluded values. If we go through this whole problem and we solve it, and we get either one of those answers, we throw that answer away and we say no solution, okay? All right, now, if we have a fraction equal to fraction, the easiest way to solve with a fraction equal to fraction is simply to cross multiply. Cross multiply. This only works if you have a fraction equal to a fraction. You just cross multiply. This 2x minus 7 multiplies up to the 2. This x plus 8 multiplies up to the 5. The reason it works is because you can multiply both sides by x plus 8. And you can multiply this equation by 2x minus 7, 2x minus 7. That's why it works. But it's just easier to say, Mr. Davies said, cross multiply, okay? And there is a reason why it works. So if I do that, I'll have a 2 times a 2x minus 7 equals a 5 times an x plus 8, okay? And then the fraction is gone. And it's just easy to solve. Looks familiar. Looks like maybe the one Brian did, doesn't it? I think I did that on purpose for our notes to make it easy. So then, you know, we're just going to distribute like Brian did. Right, Brian? We get 4x minus 14 equals a 5x plus 40. We're still solving for x, so I'm going to go minus 4x minus 4x. I'll have a negative 14 equals 1x, or x plus 40. And Brian put that also. I like that, Brian. You put x. You didn't need to put the 1x, did you? You knew 1x next same thing. Minus 40, minus 40. Get x equals negative 54. Okay, which is not either one of those answers, is it? So that's our answer. As long as we didn't get negative 8 or 3.5, then we're good. Okay, that's my answer. Okay, circle it. Done. Okay, thumbs up. Okay, example 2. Well, I have a fraction equal to a fraction, so we're going to cross multiply. And solve. I'll have a x minus 6 times an x plus 1 equals an x plus 2 times an x minus 3. Okay? And And then I'm just going to do a big FOIL problem. You know, this times this times this. I think this is the exact same problem, number 3, that I did. Remember? Same problem I did. I'm going to get an x squared plus a 1x minus a 6x minus 6, right? Equals same thing over here. I will FOIL it. I'll get a x squared minus a 3x plus a 2x minus 6. And I'll step back and let you catch up. So I just multiplied it through. It'll simplify to an x squared minus a 5x minus 6 equals x squared minus 1x minus 6. I just combined the middle terms. That's all I did, right? Okay, I recognize x squared, which is nice. So if I subtract x squared, my x squareds will cancel, right? And then I don't have to worry about factoring. It makes it pretty easy at this point because the x squareds did cancel. I'll have a negative 5x minus 6 equals a negative 1x minus 6. I'll go plus 5x, negative 6 equals a 4x minus 6, right? Plus 6, 0 equals 4x. Divide by 4 and x is 0. But before I finish, I better think about excluded values. Because if 0 is one of my excluded values, I'm going to have to throw it out. But my excluded values up here is x cannot equal 3 and x cannot equal 6. Those are my excluded values. So my answer of 3 is the answer I want, or 0. So this is my answer. I can keep that answer because those are my excluded values. And again, how do I get the excluded values? Can't divide by 0. Can't divide by 0. Check it out, Lucy. What's 3 minus 3? 3 minus 0? 0. Can't be 3. What's 6 minus 6?
0.
Can't be 6. Can't, right? Yeah. Had to wake you up a little bit.
Yeah.
I saw that. You're like kind of daydreaming, weren't you? Okay. Turn the page. Yes. Am I going too fast? Okay. Turn the page. Okay. Now, what happens if you have 3 fractions? Right?
Do you do the x plus 1 to the second one and the x plus 2 to the first one and then make it add it and then do the...
Yes. Normally, yes. Normally, yes.
Oh, yes. Well, I was trying to...
Normally, yes, but this problem actually has just this problem is unique. But normally, yeah, you make a common factor, x plus 2, x plus 2, x plus 1, x plus 1. But what if I brought this one over? See this one right here, over, brought it over. What if I took this fraction brought over? Say it again. Yes, yes. So if I can bring my second fraction over, and then, Retta, what you said is, yes, I would do that most of the time. But in this circumstance, if I brought that one over, I'd have a common denominator, right? How do I bring this fraction over? Yeah, you subtract it. So, okay, let's see. I'm going to have a 3 over x plus 1 equals a 15 over x plus 2 subtract 4 over x plus 2, okay? Okay, I just brought it over by subtracting it. Excluded values, okay? Lucy, wake up again. Sorry. So Lucy, what's negative 1 plus 1? Yeah, can't be negative 1. Lucy, what's negative 2 plus 2?
0.
So my excluded values are negative 1 and negative 2, aren't they, right?
Yeah.
Thanks, Lucy. I'll keep you engaged, huh? So we know for sure x cannot equal negative 1 and x cannot equal negative 2, okay? So if I get that answer, then I have to throw it out. Well, gratefully, we brought these two together, so they already have a common denominator, right? And that common denominator is just going to be my x plus 2. And I can go 15, subtract 4, and get 11. Now I have a fraction equal to a fraction, right? In that case, we're going to cross multiply, right? I like that because it makes it easier for me. So I'll have a 3 times an x plus 2 equals 11 times an x plus 1. And then I'm just going to distribute and solve, right? I'll get a 3x plus 6 equals 11x plus 11. I'm going to go minus 3x, so I'll have a 6 equals an 8x plus 11. Minus 11, negative 5 equals 8x. Divide by 8, x is negative 5/8, which is okay. It's not either one of these two answers, so I'll keep that answer, okay? Okay, how am I doing? Ariel, question?
Can I use the restaurant or no?
What's that?
Can I use the restaurant or no?
Yeah, absolutely, okay? Yeah, unless it's emergency, you got to go now, okay? Now, number 4. What we learned yesterday is if we can factor, sometimes it makes the common denominator easier. Because in this case, we will need a common denominator, okay? So if I can factor this third fraction into x times x plus 4, we're going to look at all 3 fractions. To get a common denominator, it has to be true for all 3 fractions. So common denominator for all 3. Fraction 1 has an x plus 4, but it does not have an x. So I'm going to multiply it by an x over x. Okay? Fraction 2 has an x, but it does not have a x plus 4. Okay? So I have a common denominator. It is x times x plus 4, and its numerator would be a 12x minus a 7x minus 28. That's a 28. I'll let you catch up, okay? I'll stop for a second. I'll let you catch up. Okay, so what I need to do is this. That's x plus 4 is my common denominator. First fraction needed an x. Second fraction needed an x plus 4. So now these 2 fractions have the x times x plus 4, okay? Right? And then I needed a 12x minus 7x minus 20. Okay, now the second fraction on the other side, we're just going to write it the way it is because it already has the common denominator. So it's still going to be the 22 over x times x plus 4. Okay? How am I doing? Now, don't cross multiply. Don't cross multiply. Here's the trick. If you get the common denominator all the way through, you could do this. You could multiply both sides by x times x plus 4, x times x plus 4 over 1 over 1. This happens, so what happens when I do that? If I multiply both sides by the common denominator, what happens? It gets rid of your fraction, doesn't it? Completely cancels your fraction. So I'm going to say this a couple of different times, okay? If you have a common denominator all the way through, then you can just get rid of it because you can multiply both sides by that common denominator and cancel it. But it has to be, it's not cross multiplication because you have the same thing on the bottom, same thing on the bottom. You see it? Same thing on the bottom, same thing on the bottom. So you can just get rid of it by multiplying by that. Okay, then it probably gets pretty easy. It really does, because now what we have is a 5x minus 28 equals 22, right? Plus 28 plus 28. 5x equals, what's that, 50? Divide by 5, and x is 10, okay? Now, there will be times when you're going to see ones that you'll have to throw answers out. But we're going to do this as a 2-day lesson. We're going to do it today, and we're also going to do it tomorrow. And if we can launch our rockets on Friday, let's do that, okay? Anybody not done with